This lesson is on the derivatives of trigonometric functions, functions like sine, cosine, and tangent. But throughout this lesson, please keep in mind that I'm always using radians. Radians are the unit we must use to talk about the calculus of these various functions. But let me remind you of the graphs of these functions. So first off, we have a unit circle. So a circle of radius 1. And there are 4 or possibly 5, if you think of it, points of interest. This is the point where x is 1, y is 0. This is the point x is 0, y is 1. This is the point x is -1, y is 0. This is the point x is 0, y is -1, and then we're back to 1, 0. Why do I use that initial point twice? Because it's 0 radians. It's also 2 pi radians all the way around. Pi radians here, so halfway here is pi over 2 radians, 3/4 of the way, 3 pi over 2 radians. And the x value is cosine and the y value is sine. So let's go ahead and graph the sine function first. We're going from 0 to 2 pi, goes up to 1, goes down to -1. Pi is in the middle, pi over 2 here, 3 pi over 2 here. So let's look at our y values. That's the function of sine. So at 0 radians, sine is 0. At pi over 2, we're up to 1. At pi, we're down to 0. At 3 pi over 2, the y value is -1. And at 2 pi, we're back to 0. So this is the fundamental period of the sine function. The sine function are the y values on the unit circle. So this is the fundamental period of y equals sine x. It's a graph you want to recognize. The x values are going to give us the cosine function. So we do the same thing. 1 to -1 are the range of values that we have. 0 to 2 pi, halfway is pi, 1/4 of the way is pi over 2, 3/4 of the way, 3 pi over 2. But notice the x value here starts at 1. At pi over 2, it goes to 0. At pi, the x value goes to -1. 3 pi over 2 to 0, 2 pi back to 1. So here is our graph of cosine. You want to keep those ideas in mind. Now, what do we want to do? We want to talk about the derivative. So the issue is if I have f of x equals sine x, what is f prime of x? That, of course, is the limit as h goes to 0 of f of x plus h minus f of x over h. Well, knowing that, then, my derivative of sine is approximately what? My derivative of sine x would be approximately sine of x plus some small number, I'm going to use 0.001, minus sine of x, that's f of x is sine of x, of course, divided by that same small number, divided by 0.001. This should give me an approximation for the derivative of the sine function. So let's go to Desmos and take a look at that and see what that looks like. So we'll first go ahead and graph our sine x. Fine. And then I want to take a look at that sine of x plus 0.001 minus sine of x over 0.001. So sine f of x plus h using a small one of 0.001 minus sine of x divided by 0.001. What does that graph look like? Well, take a look at that graph in purple. Does that look familiar? Does that look familiar? It is the graph of cos x. 1, pi over 2, negative 1, back to 0, 3 pi over 2, back to 1. So the derivative of sine x is cosine x. Excuse me, the derivative of sine x is cosine x is what I want to say. The derivative of sine x is cosine x. Now, that's not a proof, again, but it's obviously suggested by that, right? The derivative of sine x is cosine x. That's what we get from looking at the graphs. Now, what about cos x? If I wanted to work with cos x, what could I say? Well, if I'm going to say g of x is cosine x, right? The derivative of that would be limit as h goes to 0, g of x plus h minus g of x over h. Okay, so that the derivative of cos x is approximately, instead of a limit, let's just use a small value of like 0.001. How about cosine of x plus 0.001 minus cosine of x divided by 0.001. And what does that look like? So let's again go to Desmos. And we'll turn these off. And let's go to y equals cosine x, which is as you expected it to be. And then its derivative, f of x plus h, so cosine of x plus a small number minus cos of x divided by that small number. And let's take a look at that function. Is that one you recognize? Is that one you recognize? So look at the function in red. Focus on that. That's the derivative of cosine. Is that the same as sine? Well, sine looks like this. Up, down, down, up. Whereas the graph we just looked at on Desmos was down, up, up, down. Similar. So how does the derivative of cosine compare to sine? You recognize the red graph, derivative of cosine, is the opposite of the green one, is the opposite of sine x. So let's take a look at that. I'll go ahead and I'll graph in y equals negative sine x, which notice that blue function is the same as the red one, the derivative of cosine x. So that's our other fact that we can use. We can say the derivative of cosine x is negative sine x. So we have two facts to work with. Derivative of sine x is cosine x. Derivative of cosine x is negative sine x. And from those two facts, we build the derivatives of the other trig functions. So here we go. Write those two facts down. Derivative with respect to x of sine x is cos x. Derivative with respect to x of cos x is minus sine x. Now, those aren't proofs, but awfully good suggestions from looking at the behavior of the graph. So our next favorite trig function is tangent. And we need to remember that tangent is sine divided by cosine. And let's remind ourselves of the quotient rule. The derivative with respect to x of u over v is u prime v minus uv prime all over v squared. So in this case, u is sine x, v is cos x, u prime is the derivative of sine x, which is cos x. V prime is the derivative of cos x, which is minus sine x. So putting that together then, the derivative of tangent x is u prime v, u prime v, u prime v, cos x times cos x minus uv prime minus sine x times negative sine x all over v squared all over cos x squared, which is what? What do we get here? Cos x times cos x is cos squared x, or cos x squared, minus a negative plus sine x squared all over cos x squared, which of course is the same as cos squared x plus sine squared x over cos squared x. Cos squared x plus sine squared x, we know from trigonometry, is 1 over cos squared x. Well, 1 over cos is secant, so 1 over cos squared x is secant squared x. So that's our third rule to remember, that the derivative of tangent x is secant squared x. So now we have 3 facts that we can use. Let's write them all down. Derivative of sine is cosine, so the derivative with respect to x of sine x is cosine x. The derivative with respect to x of cosine x is minus sine x, and the derivative with respect to x of tangent x is secant squared x. So a quick follow-up to derivative of tangent would be derivative of cotangent, which is the same thing as the derivative of cosine x over sine x. And we will again do this with the quotient rule. The derivative with respect to x of u over v is u prime v minus uv prime over v squared. So in our case here, u is cos x this time. V is sine x. U prime, derivative of cosine x, is minus sine x. V prime, derivative of sine x, is cos x. So what do we get? The derivative of cotangent x is u prime v, so negative sine x times sine x, minus uv prime minus cos x, all over v squared, all over sine x squared. So I get the derivative with respect to x of cotangent x is negative sine, so negative sine squared x, minus cos minus cos squared x over sine squared x. And let's think about this. I can factor a negative 1 out of the numerator. Negative 1 times sine squared x plus cos squared x over sine squared x. Well, sine squared plus cos squared x is just 1. So I get negative 1 times 1 over sine squared x, which is negative 1 over sine squared x, which is negative cosecant squared x. So that's one more fact to add to our list. The derivative of cotangent is negative cosecant squared x. And again, you want to memorize these 6 derivatives because they do come in handy, especially when you start doing integrals later in calculus. Okay, so we have 4 of the 6 trig functions done. We have 2 more to do, namely secant and cosecant. So let's quickly do those. The derivative of secant is what? Derivative of secant. Secant, of course, is 1 over cosine. So again, I'm going to use the quotient rule, which is derivative with respect to x of u over v is u prime v minus uv prime over v squared. U is 1, v is cos x, u prime is 0, v prime is minus sine x. So what do we get? We get the derivative of secant x is u prime v 0 times cos x minus uv prime minus 1 times negative sine x all over v squared all over cos x squared, which gives me 0 plus 1 sine x. Upstairs, we just have sine x over cos x times cos x. Now, the way this is usually memorized is as follows. We usually think of this as 1 over cosine x times sine x over cosine x. 1 over cosine x is, of course, secant. Sine x over cosine x is tangent. So our fifth rule is the derivative of secant is sec x tan x. And there's one more for us to do, namely cosecant. The derivative with respect to x of cosecant x is the derivative with respect to x of 1 over sine x. So same strategy, quotient rule, derivative with respect to x of u over v is u prime v minus u v prime over v squared. U is 1, v is sine x, u prime is 0, v prime is cos x. So we get the derivative of cosecant x is u prime v is 0 times sine x minus uv prime minus 1 times cos x all over v squared all over sine x squared. 0 minus 1, so negative cos x over sine x times sine x, which I'm going to write this way. Now, how do we usually memorize this? Negative, and then 1 over sine x, and then cos x over sine x, which is negative cosecant x cotangent x. So that's our derivative with respect to x of cosecant x. So 6 facts to begin to memorize, 6 facts to add to your list. So let's conclude with those. The derivatives of all 6 trig functions. The derivative of sine x is cosine x. The derivative of cosine x is minus sine x. The derivative of tangent x is secant squared x. And then where did we go? Then we went to the derivative of secant, which is secant tangent. The derivative of cosecant is minus cosecant cotangent. And then the derivative of cotangent is minus cosecant squared x. I just want you to notice something. We have 3 cofunctions, cosine, cosecant, and cotangent. And I'd like you to notice that the derivatives of all 3 cofunctions are negative. So that's a little trick you can use to help you memorize those 6 rules.